This next video is going to show how to find the least common denominator of a rational polynomial, of a rational expression. So the first thing you need to realize is that we want all the denominators to divide into this least common denominator. So, for example, if I would have, say, an x is the denominator in one of them and an x squared in the other, then what I would need is my common denominator would be x squared. So as you can see that for two factors that basically are the same, an x and an x squared, I'm going to use the one with the highest degree on it, or the highest power, because if I just picked an x as the common denominator, the one with the least exponent, then the x squared couldn't divide evenly into that, and that's what we need it to do for the least common denominator. So that's one of the key things we're going to have to look for. Is we're going to have to find the highest power of all the different factors that are in the denominator. And so the first step would be, of course, we're going to have to factor the denominators, that all the way down to the prime factorization. And that'll tell us what the factors are. Then for each individual factor, we're going to figure out which one has the highest power in it, or the highest exponent on it. And that's what we're going to use for that particular factor on our common denominator. And we'll just have to keep going like that until we've gone through all the different factors in our denominator. So let's take a look at how this works. So for this particular problem, I have 1 over 5x and 3 over x cubed, and I want to find the least common denominator. And so let's start, and we've got a 5. So we have a 5 is one of the factors in the denominator. And let's look at the next term, and we don't see a 5, so obviously that 5 has to be the one with the highest power. Then let's move over to the next factor, and we have a factor of x. Okay, so I have an x in this term, but I have an x cubed in this one, so the factor that I'm going to use that's related to the x is going to be x cubed. And now, since I've used all my factors in the denominator, my greatest common factor is going to be 5x cubed. And you can see that 5x can divide into there, and also x cubed can divide into there. Now that I found the common denominator, let's go ahead and change the terms that I have into equivalent terms so that they can have a common denominator. So, for example, I would have 1 over 5x, and I know that it's got to move or become an equivalent fraction that has 5x cubed as the common denominator, or as its denominator. So I go from 5x to x cubed, so I would have to multiply this term by x squared over x squared, meaning that the term would be, my numerator would be x squared. So this is the 1 over 5x has been transformed into equivalent fraction. Let's do that for the next term, 3 over x cubed. And we know that it also has to have a denominator of 5x cubed. So for the x cubed to become 5x cubed, the denominator will have to multiply by 5, so will the numerator. So that would be 15 over 5x cubed to do my two new terms. Let's move to another example. So let's find out what our common denominator is going to be. And we can see that we have an x in the first term, and we have an x squared in the second one. So between the x and the x squared has the higher power on it. Then we have an x plus 1. And we don't have any x plus 1 in the second term. Then we have an x plus 2. So my least common denominator will be x squared times x plus 1 times x plus 2. So let's go ahead and change these terms into equivalent fractions. So I have 5 over x times x plus 1. And it's going to have to become a new equivalent fraction with the denominator of x squared times x plus 1 times x plus 2. So for x times x plus 1 to become this new denominator, you can see that what it actually has multiplied by is the x became x squared, and then I also added an x plus 2, so move these terms a little bit. So it's going to have to multiply by x over x plus times x plus 2, and of course the numerator has to have the same thing. So this term would be 5x times x plus 2 would be my equivalent fraction. Let's move to the next term. So I've got 6 all over x squared times x plus 2, and it has to have a new denominator that's x squared, x plus 1 times x plus 2. Okay, so what it would need to multiply by, it's already got the x squared and x plus 2, so it has to multiply by x plus 1 all over x plus 1. That would give me 6 times x plus 1. So we'll do another example. Okay, so in this example, I have two terms, 15 over 8x squared plus 32x, 3 over 2x plus 8. And notice that these denominators are not factored yet. So let's go ahead and factor them completely to see what our factors are. So the first thing in the first term, you can notice I can pull an 8x out. So if I pull an 8x out, that would give me x plus 4. So that's my factorization so far. In the next one, I can take a 2 out, and I'm going to get x plus 4. Now, the 8 is really composed of 2 cubed. So I'm going to factor that also. So you can see that we've taken 8 and we've made it 2 cubed. So this is really the prime factorization of the denominator in the first term. The second one was already factored enough. So let's go ahead and find the LCD. Okay, so let's start with the first factor in the first term. I have a 2 cubed. And over in the second term, I have a 2. So between 2 cubed and 2, I'm going to want to use 2 cubed. It has the higher exponent. Now you can see why I actually broke 8 up into its factor of 2 cubed. Now let's go ahead and we can see that we have, move over to the next term, I have an x. And I don't have an x in the denominator of the other term, so x is going to have to be in my denominator. Then I have x plus 4, and of course that's to the first power. And x plus 4 in the other term is also to the first power, so actually I should have split these up, I guess, like this, the way I was doing it before, and then I have an x plus 4. And so you can see that when I combine those, my common denominator is going to be 2 cubed times x plus 4. So let's change all these terms into new terms. So my original term was 15 all over 8. Let's use the factored form. 2 cubed x over x plus 4. It's going to become a new fraction, or a new equivalent fraction, and it's going to have a denominator of 2 cubed x times x plus 4. So the 2 cubed is there. The 2 cubed is in the new denominator. We have x. X is in the denominator, and so is x plus 4. So there's really nothing that needs to be multiplied by that term. Let's move to the second term. And it needs to become a new fraction with a denominator of 2 cubed x times x plus 4. So let's see what needs to be multiplied. It needs to be multiplied by to get that. So I have a 2. I need a 2 cubed. Okay, so I'm going to have to multiply by 2 squared. And then I have an x plus 4. I need to have an x. I don't have an x in the original denominator, so it's going to have x there. And then you can see that I also have an x plus 4. So I'm going to really need to multiply by 2 squared times x, which is really 4x. To give me the new denominator, which would be the new term, which is 12x, over the common denominator. And that is the part for finding common denominators.